Alright, so you're getting at least 2 pieces of paper, alright, and what you're going to do with your ruler is make a, as best as you can, some kind of straight edge, make a triangle, and you're going to go ahead and cut it out with your scissors. So once you've done that and you've cut it out, what I'd like everyone to do is cut off the 3 corners, doesn't matter where, I'm just going to cut them off. I'm cut off 1 corner, 2nd corner, and 3rd corner. You can get rid of what's left, and now you're looking at the 3 angles of this triangle that you just cut off. And what I'd like you to do somewhere, on your table, whatever, your notebook, is you're arranging them to see what's so special about these 3 angles. So if I go ahead and try to match it up, see, this, and like this, all different kinds of ways you could kind of think of doing it the other way. They will, when you do this, I'm having a hard time here, whoops, yep, that is me doing this. If you go ahead and figure things out, it's like a puzzle here. They all line up on a straight line as best as you can, depending on how you cut them out, and with your ruler, to equal 180, all on a straight line, the 3 angles. Now I think everyone knew this theorem, the triangle angle sum theorem, and that's just a visual by cutting that any 3 angles of any type of triangle always add up to 180 degrees because they're laying on the straight line. Okay, so let's push this down. We're going to do these 2 practice problems. We're going to be solving it for x and listing sides from largest to smallest in this one. Solving for x here and listing the sides from smallest to largest, and I'll talk about that. So we know all angles in a triangle add up to 180. So this is our algebra in the geometry, so we're going to be making our equation, taking all 3 of these angles to equal 180 degrees. And now we're going to go ahead and solve it for x, which is our basic equation. So you want to combine these like terms on the left. So 130 plus 2, that's 132. And now we're just going to go ahead and finish it. 132 minus the 180, I believe, is 48. Divide by 8. So x here is 6. Now if I was to plug this back in the equation, 8 times 6 is 48, plus 2, that's 50 degrees, this angle here. So I want you guys to think about, what do you think would be the largest side to the smallest? So we're not giving anything about the sides, all we're given is the angles. We're given 50 degrees here, 60 degrees here, 70 degrees here. So there is another special theorem that the largest side is opposite the largest angle. Largest side, opposite largest angle. And the same thing for the smallest side. It's opposite the smallest angle. So the largest angle here is 70 degrees. So what's the side opposite of it? Right here, XY. So XY is my largest side. Alright, what will come next? Because we have to go down to the smallest, would be 60. What side is opposite of 60? XZ. That would come next. And then what is the last side? That's the smallest. Opposite of 50 degrees is YZ. Alright, let's try one more. Again, solving this for x, we have a triangle. I'm trying to figure out what's the missing x there. Again, we have 3 angles, so we know it adds up to 180. So we have x plus 59. X plus 11 to plus 84, excuse me, equal 180. Alright, now we're going to combine our like terms. We got 2 x's. We got to add 59, 11, and 84. That's 154. Subtract, oops, 154 that is. Excuse me. So 2x to equal 26. So x is 13, we're going to divide that in half. So now let's go back and plug this in. So 13 plus 11 here, what is that? 13 plus 11 is 24 degrees. And then we're going to plug in 13 here. 13 plus 59 is 72 degrees. So now we have to find the sides from smallest to largest. Alright, so the smallest angle is this one, 24, which is on F. What's the side opposite of F? ED, or DE. That's the smallest. Then the next one is 72 degrees, D, opposite of D, right, is EF, or FE, right? And then the last one, the biggest side, is opposite of E, 84 degrees, which is DF, or FD. Alright, going on to our last activity with the paper. Alright, so you're going to make another triangle here. Another one. And I'm going to extend, and I'll show you in a minute, one of these sides of the triangle out. So I'm making an exterior angle, just like this. So I have a triangle with the side extended out for an exterior angle. We're going to label 3 different things here. So we're going to label these 2 angles, 1 and 2. 1 and 2. And then we're going to label this one on the outside is angle 3. So we are going to cut this one out, but when you cut it out, the most important thing is you want to include this outside exterior angle. So you're cutting all along the bottom, all along that side there. You can kind of go as far down as you can, but don't cut off angle 3. Alright, once you've done that, what I'd like everyone to do is cut off, like we did before, 2 angles now, 1 and 2. Alright, so this is what I have left. I'm just going to put this up here. Is the thing up here? Yeah, okay. So now we're taking 1 and 2. What I'd like everyone to look at is, okay, what's so special about these 2 angles? Does it fit in this area in here perfectly on this line with this piece of this angle for 3? So you're taking these and seeing if you could figure out, does it actually go and lay perfectly nice? And as you can see, it does. So here's our last theorem for today. So we're going to move it over. We're going to move it over. And it's called the triangle exterior angle theorem. So this is pretty similar to what we just did with the paper. Here I have it flipped around because it's going to be flipped around. They are saying that if I take an exterior angle, any of the exterior angles, I'm just looking at one of them here, it's going to add up to these 2 inside angles, but they have a special name. They're called remote interior angles. Now we don't want to include the angle that's next to this outside angle because these 2 have to add up to how much? 180 degrees, right? Because it's on a straight line. So the 2 that are inside but right not next to it add up to that exterior angle. So let's take a look at the example over here. It's asking us to name the exterior angle and the 2 remote interior angles just to practice. So the exterior angle here is angle, the exterior here is angle BCD. Right, this one here. Now what are the 2 remote interior angles? Can you figure those out? Is it this one? Nope. It's angle A and it's angle B. Those are the remote interior. So I don't know why they call it remote, but they do. So it's this one and this one. Alright, looking at this picture here, it's weird, this triangle. It's really skinny, like a scalene triangle. So it's got 1, 2, and 3 in the triangle. It's got 4 over here. What's the exterior angle? Well, that's angle 4. That's the exterior angle. And can you guess what the remote interior angles are? 1 and 2. Those are the remote interior. Alright, so let's take a look at 2 examples using algebra for this one, which is down here. 2 for practice. Alright, here's a picture here. We're solving it for x. Alright, so here it is. We have an outside angle 120. Now, we know our new theorem now, so we know that these 2 remote interior angles are going to add up to 120. So x plus 150 is 120. So what's left from 120 from 50? That is 70 degrees.
60. Oh, it's not, Mom. It's 60.
No, it's 70.
Oh, it is 70.
You could have also figured this out by getting the angle next to 120, because we know this is a straight line, so that adds up to 180. So that would be 60 degrees. And then you could go back to this theorem over here, triangle angle sum theorem, and add those two and subtract it from 180. So you could do it that way, or you could use this new theorem. Either way is fine. Alright, last one, number 2, solve this for x. Alright, this was the thing that I talked about before that I erased. This means it's what? Perpendicular. It's 90 degrees because it's got the box. So this is a 90-degree angle here. Again, these are the remote interior. Now we're looking for the outside. So we know 70 plus 90 is going to equal that outside. So that's 160 degrees. If I wanted to get this angle right here, well, what's left of 180 from the 160, because it's on the straight line? 20 degrees, but I didn't ask you that. Alright, done.